Okay, suppose that this is the circuit where this nodal voltage theorem is to be applied, and this EMF source is E1 and this is say E2, and this is taken as a reference node. Okay, and the rest are these resistances. So we have to apply the KCL and KVL and the potential difference formulas to calculate the unknown values. Okay, suppose that we are given the values of E1 and E2, R1, R2, R3 resistances, whichever are given in these circuits. Let us assume that these values are known to us. So what precaution you have to take while calculating any DC network circuit? That units is expressed in volts, then resistance is to be expressed in ohms, and current is to be expressed in amperes. Okay, so if at all there is any change, then it is better to change those circuit values into SI system. Okay, now let us suppose that the current I1 is flowing through this R1 and this node is appearing, so current is divided as I2, and since this is R4, you can say the current which is flowing here is I4. Okay, now this voltage source is having this positive terminal, so you can take this current as I3, and this is taken as I5. Okay, so these are the node current distribution is taking place. Say this is A and B. So the voltage which is corresponding to this nodes can be assigned as VA and VB. So this is the potential which these nodes are having. Now we can apply the KCL and potential difference. So first add that this I1 is incoming current, this I2 and I4 are outgoing current. Okay, so the first equation will be I1 equal to I2 plus I4. Okay, so what is this I1 current? According to Ohm's law, whenever there is a potential difference between the two nodes or the terminals, the current flows. So this I1 can be written as E1 minus VA. This is the potential difference upon the resistance R1. Okay. Similarly, this I2 can be written as I2 is the current which is flowing in this branch. So this is VA minus VB upon R2. Okay, and third part is I4. So here what is happening? So this is the I4 current which is flowing in this branch. Okay, so this is VA terminal and reference is at zero potential. So we can write as VA upon R4. Okay, so this is one of the couple of the equations. One is KCL based, second is potential difference. Similarly, we can see that at this node, at node B, I5 is the outgoing current and I2 and I3 are the incoming currents. So I2 can be defined as, sorry, I5. This I5 can be defined as, this VB is the potential difference minus 0 upon R5. Okay. And I2 remains same as this. Okay. So we can write current equation I5 is equal to I2. I2 remains same plus I3 becomes, this is I3 current. So here the potential difference is E2 minus V, E2 minus VB. This is the potential difference, and it is divided by the resistance, which is R. Okay. This is I2 current, this is I3 current, and I5 I have just mentioned that it is VB upon R5. VB upon R5. Okay. So we are having 4 equations, 2 KCL based and 2 potential difference based. So few of the parameters like resistances and EMFs may be known values, and some of the currents may be unknown values. So by solving these type of circuits, to solve these types of, we can adopt this method. Okay. Sometimes a question arises that what if we direction of the current? So you need not to take care of that. You can assign any direction of the current. If the direction is same as required, then it is good enough. But if the direction is not same, then the final result will have the negative value of the current. So if you have assigned the current direction from LHS to RHS and say the result is 2 amperes, then it is good enough. But if the result comes as minus 2 amperes, it means that the current flowing in the branch is in the reverse direction, or you can say from RHS to LHS. Okay. So which type of questions or unknowns can be solved using this nodal value theorem? First of all, if some resistances is given and EMF is given, for example, resistance is given, EMF is given, and current is not known to us. So this current can be solved. Next is that if resistances are given and we have calculated the current using this method, then it is quite possible that the drops corresponding to different resistance can be asked to calculate. Okay. Then we have to multiply For example, say R1 is given, then I1 R1 is the drop. If this is I1, okay. Sometimes the power associated with those resistances can be asked. Again, nothing is to be worried of. I1, I square R is the formula which is well known to you. So if I1 is the current and if R1 is the resistance, then the power which is associative can be this. So this is the power consumed by the resistance. Okay. So these are the possible types of the questions and the expectations from the numerical. So suppose this is the circuit in which few resistances are given and few voltage sources are given. Suppose this node is given A value, this is given B value, and this is assigned C, and this is 20 volts, and you can say let us this be 15 volts. If some unit is given, it is fine. If it is not given, it is assumed to be volts. Okay. Similarly, for resistances, if it is required to be mentioned kilo ohms, it will be given as kilo ohms. If it is not given, then it is assumed to be ohms only. For example, let us this is 1 is given, so it is 1 ohm, and say this is 0.5 ohms. Say this is 1 ohm, this is 2 ohm, so again 1 ohm. Okay, so these are the nodes ABC, where C is the reference node and two voltage sources are given, resistances are given. We are required to find the power consumed in the passive elements network and say network. Okay. Thing first. So first of all, we have to assign in the suppose this is the current one. This is the current I2. This is I3 flowing. Here again, there will be distribution of current. So if the this sending current phi, the current which will flowing out of B. So same pattern is to be followed, which we have explained earlier, that there were two nodes. Okay. So in these two nodes, first of all, KCL is to be applied as explained in the earlier examples, and potential difference formula is to be applied as explained, and the current which is flowing to the different branches is calculated. Okay. So here we have seen that two EMFs were known and all the resistances were known, and the unknown number of currents were 5: I1, I2, I3, I4, I5. Okay, so I have denoted II, where I is equal to 1 to 5. So these are the 5 unknowns. So we have how many equations do we have. First is the A node, this is B node. Okay, so two KCL equations we are aware, and rest by substituting the potential difference formula we can get the values of different currents. If the direction, if the current comes out to be positive, then the direction remains same, else it is reversed. So when we are aware of all these currents, then what we will do, we will calculate the power consumed by the resistance or the passive elements. This is the I1 square R1. Similarly, we can calculate different power consumption